Recently, the battlefield in Ukraine witnessed an extraordinary clash that has captivated military analysts worldwide. Dramatic footage captured the intense close-quarters combat between an American-supplied M2 Bradley fighting vehicle and a Russian BMP infantry fighting vehicle. This unprecedented encounter highlights the fierce dynamics of modern armored warfare and provides critical insights into the performance of Western and Russian military hardware in real-world combat scenarios. Technical specifications comparison. The M2A2 Bradley and BMP-2 infantry fighting vehicles exemplify contrasting design philosophies, each tailored to different battlefield priorities. While the Bradley emphasizes protection and firepower, the BMP-2 prioritizes mobility and agility, reflecting the strategic doctrines of their respective origins. The M2A2 Bradley, weighing 27.6 tons, boasts advanced protection features, including spaced laminate armor capable of withstanding 30mm APDS rounds and RPGs on the front, and 4.5mm rounds from 200 meters on the sides. Its formidable firepower features a 25mm M242 chain gun with 900 rounds, 2 Telo anti-tank missile launchers, and a 7.62mm coaxial machine gun. Enhanced survivability is ensured by automatic fire extinguishers and NBC protection systems, showcasing its ability to endure harsh combat conditions. In contrast, the 4.3-ton BMP-2 reflects Soviet-era design priorities, with its compact dimensions, 6.72 meters long and 2.45 meters high, and lightweight construction, enabling superior maneuverability in diverse terrains. Its armament includes a 30mm .242 cannon, complemented by a crew capacity of 37 passengers. Capable of reaching speeds up to 65 km/h and operating over a range of 550 to 600 kilometers, the BMP-2 provides tactical versatility. Its armor, while lighter, protects against 23mm armor-piercing rounds on the front and 7.62mm bullets on the sides. Bradley's Advanced Integrated Sight Unit, ISU, delivers a technological edge. It features a laser rangefinder with a range of up to 10 kilometers and day and thermal imaging capabilities with X4 and X12 magnification. These enhancements ensure superior target acquisition compared to BMP-2's more basic optical systems. However, the BMP-2 compensates with unique design advantages, such as the 30mm Canon 75-degree elevation capability, enabling effective engagement of low-flying aircraft and urban targets. Its dual-belt feed system grants instant access to all 500 rounds of ammunition, although this capacity is smaller than the Bradleys. Both vehicles carry anti-tank guided missiles, with the BMP-2's Concours missile slightly surpassing the TOLA system in range. Nonetheless, Bradley's advanced fire control systems and thermal imaging granted a decisive edge in precision targeting and engagement. In summary, the M2A2 Bradley excels in protection and advanced targeting, making it a robust choice for sustained combat. Meanwhile, the BMP-2's mobility and versatility highlight its effectiveness in dynamic and varied battlefield scenarios. Armor and protection systems. Protection systems play a pivotal role in distinguishing the combat effectiveness of the M2 Bradley and BMP-2. The M2A4E1 variant of the Bradley, recently upgraded with the Israeli Iron Fist light active protection system, underscores the U.S. Army's focus on survivability. The system integrates advanced countermeasures including 2 countermeasure launchers, 4 sensor arrays with ESA radars, infrared cameras for threat detection, and high-explosive fragmentation interceptors. The Bradley's base armor employs a combination of a 25.4mm thick aluminum hull and a 9.5mm steel plate at the bottom front, designed for mine protection. This robust construction enables the Bradley to resist 30mm caliber rounds on its frontal arc, providing significant survivability in high-intensity combat scenarios. Additional enhancements, such as spaced laminate belts and high-hardness steel skirts, have increased its weight to 33 tons, further improving crew protection. By contrast, the BMP-2's armor design, while functional, exposes critical vulnerabilities. Its hull armor averages 23mm in thickness, offering resistance against 23mm armor, piercing rounds from 500 meters frontally, 2.7mm rounds from the same angle, and 7.62mm rounds on its sides. Although the BMP-2 introduced improvements over its predecessor, including a more protected two-man turret shared by the commander and gunner. Its hull remains highly susceptible to shaped charge missiles and top-down attacks from loitering munitions and artillery strikes. Recent combat experiences in Ukraine highlight these vulnerabilities, as BMP-1 and BMP-2 vehicles have proven particularly exposed to modern weaponry targeting weaker armor areas. In comparison, the Bradley's advanced protection systems, while untested against certain threats like top-down attacks, suggest better resilience due to its comprehensive armor enhancements. The M2 Bradley's superior protection features, including its advanced active defense systems and robust armor composition, provide a decisive edge in safeguarding crew and vehicle integrity. Conversely, the BMP-2's lighter armor and limited defensive capabilities make it more vulnerable in modern battlefield conditions, particularly against sophisticated weapons and combat systems. In contrast, the BMP-2's lighter armor and limited defensive capabilities leave it vulnerable to modern threats, a disadvantage further compounded when facing Bradley's superior weapon systems. Ukrainian combat scenarios have vividly illustrated Bradley's battlefield superiority, where its enhanced survivability and firepower have consistently outperformed Russian armored vehicles, underscoring its decisive role in modern warfare. At the heart of the Bradley's firepower is the M242 Bushmaster chain gun, capable of firing up to 200 rounds per minute. This primary armament boasts a low ADO out of 900 rounds, with 300 ready for immediate use and 600 in reserve. Its ammunition versatility includes M792 high-explosive incendiary fragmentation shells, M791 armor-piercing rounds, and M919 APS-ST-depleted uranium penetrators. Ukrainian forces have effectively utilized the Bushmaster to neutralize Russian armored vehicles, underscoring its adaptability in diverse combat scenarios. Complementing the Bushmaster is the Bradley's twin-beam 71 Tala missile launchers, mounted on the left side of the turret. With a range of 3.75 kilometers and a capacity for 7 missiles per vehicle, the Tala system has proven instrumental in engaging and destroying Russian T-72B3, M tanks and BMP-3 infantry fighting vehicles. This extended anti-armor capability has been decisive in Ukrainian operations, providing the ability to strike heavily armored targets from a safe distance. The Bradley's fire control system further amplifies its effectiveness. The improved Bradley Acquisition System, IBIS, integrates second-generation forward-looking infrared, FLIR, for enhanced thermal imaging, a day television camera for visible light targeting, a dual-target tracker for simultaneous threat engagement, and an eye-safe laser rangefinder for precise distance measurements. The IBOS Block 2 upgrade adds high-definition color imagery, greatly improving target discrimination and situational awareness. In Ukrainian combat operations, the Bradley's advanced fire control system has been a significant force multiplier. Its ability to engage targets at standoff distances reduces risk to personnel and equipment. Ukrainian infantry commanders have reported that the dual-target tracker, combined with the thermal sight system, has been pivotal in defeating Russian armored units, allowing simultaneous engagement of multiple threats during complex engagements. The M2 Bradley's integration of powerful armaments, advanced targeting systems, and long-range missile capabilities has made it a formidable asset on the modern battlefield. Its performance in Ukraine exemplifies the vehicle's ability to adapt to and dominate in high-intensity combat environments. Tactical advantages in Ukraine. In Ukraine, Bradley's advanced targeting, thermal imaging, and battlefield awareness systems have proven critical in redefining the role of infantry fighting vehicles. These capabilities have enabled Ukrainian forces to maintain a decisive tactical edge, outmaneuvering and outgunning Russian armored units. By seamlessly blending superior firepower with unmatched situational awareness, the M2 Bradley has become an indispensable tool in modern battlefield strategy, cementing its reputation as a game-changing military asset. Central to Bradley's success is its SATA-EE thermal vision system, a cutting-edge advancement in target acquisition technology. This system allows for target detection at distances of up to 5 miles, with a resolution of 1,316 pixels per inch by 480. The high-resolution thermal imaging enables Bradley crews to identify and engage Russian vehicles, many of which lack equivalent systems. These capabilities provide critical advantages, including the ability to detect threats beyond the maximum range of weapon systems, maintain effectiveness in all weather conditions, and excel in night combat scenarios. Despite its substantial weight, the M2 Bradley also excels in maneuverability, proving effective across diverse terrains in Ukraine. Its larger track profile provides superior adaptability in muddy environments, while its mobility in urban areas and open fields matches or surpasses lighter Russian vehicles. Ukrainian operators have consistently reported successful operations in both confined urban settings and expansive rural battlefields, with the Bradley effectively combining agility with firepower. Another key factor in Bradley's battlefield superiority is the improved Bradley Acquisition System, IBOS, which fundamentally enhances situational awareness. Equipped with a second-generation forward-looking infrared thermal sight, a day television camera, and a dual-target tracker, the IBOS enables Ukrainian crews to maintain superior battlefield awareness in various combat scenarios. The Block 2 upgrade, featuring high-definition color imagery, has further refined object discrimination on the battlefield, allowing for the precise identification of Russian armored vehicles. The IBOS also includes a dual-axis stabilized head mirror assembly, ensuring accurate target tracking even while the vehicle is in motion. This capability has been instrumental in engagements where Ukrainian forces successfully leveraged Bradley's targeting systems to disable high-value enemy targets. For instance, near Avdiivka, 2 Bradleys effectively engaged and destroyed a T-90M tank, showcasing the tactical edge provided by these advanced systems. The M2 Bradley's advanced thermal imaging, maneuverability, and battlefield awareness systems have given Ukrainian forces a significant tactical advantage. By allowing crews to detect, identify, and engage threats beyond the effective range of Russian vehicles, the Bradley has proven itself a critical asset in maintaining operational superiority on the modern battlefield. Combat performance statistics. Statistical analysis of combat operations in Ukraine provides valuable insights into the performance of both the M2 Bradley fighting vehicle and its Russian counterparts. Since the beginning of 2022, the United States has provided Ukraine with more than 300 Me-2 Bradleys, which have proven to be a pivotal asset in the conflict. Combat data reveals a significant disparity in vehicle losses between Russian and Ukrainian forces. Over 28 months, Russia has lost around 4,000 armored personnel carriers, APCs, and infantry fighting vehicles, IFVs, which equates to an average of 150 vehicles per month. In comparison, Ukrainian forces have lost approximately 1,000 APCs and IFVs since February 2022. Notably, 68 M2 Bradleys have been reported as destroyed, damaged, or abandoned, with around 65% of Ukraine's Bradley fleet taken out of operation as of May. Meanwhile, Russian BMP-3 losses during the same period exceeded 277 vehicles, highlighting Bradley's comparative success in engagements. The success rate of the M2 Bradley in direct combat engagements, particularly around the Avdiivka region, has been impressive. Ukrainian forces using Bradleys have achieved significant victories against Russian armored vehicles. This success can be attributed to several factors, including the vehicle's ready ammunition capacity of 300 rounds, which provides immediate firepower. The Bradley's total ammunition capacity of 900 rounds allows it to sustain its effectiveness in prolonged engagements. Additionally, its engagement range, which exceeds 3,000 meters, and superior thermal imaging capabilities have proven invaluable in identifying and neutralizing targets at extended distances. These attributes make the Bradley highly effective in combat situations, especially when compared to Russian vehicles that lack similar advanced systems. However, maintaining operational readiness for the M2 Bradley requires consistent and detailed maintenance due to its complex electrical systems. Key maintenance tasks focus on ensuring the vehicle's electrical systems and mechanical components remain in optimal condition. These include regular battery checks, proper shutdown procedures, and ensuring that essential fluid levels, such as engine oil, transmission fluid, and final drive oil, are properly monitored. The frequency of maintenance activities has increased with the intensity of combat operations, as Ukrainian forces work tirelessly to ensure the Bradley's combat readiness. Moreover, battlefield repairs have become a critical part of keeping the vehicle operational, with Ukrainian maintenance teams developing specialized procedures for quick repairs on the front lines. The intensity of modern armored warfare is underscored by the loss rates of vehicles in the conflict. Russian forces have seen monthly vehicle losses peak at 288 APCs and IFVs in recent engagements, emphasizing the effectiveness of Western-supplied vehicles like the M2 Bradley in combat. While the maintenance burden remains a significant challenge, Bradley's performance continues to demonstrate its value to Ukrainian forces. It remains a vital asset in Ukraine's efforts to combat Russian armored units, showcasing its resilience, advanced targeting systems, and overall effectiveness on the battlefield. Close combat analysis. In light of these ongoing operations, recent close combat engagements between M2 Bradley and BMP-2 vehicles in Ukraine offer invaluable data on the effectiveness of modern armored warfare. These confrontations have provided critical insights into the performance and engagement strategies of both fighting vehicles. Through detailed analysis, these encounters have shed light on key aspects such as operational parameters, combat effectiveness, and the role of advanced technologies in shaping modern battlefield tactics. This combined data on vehicle losses and combat engagements reinforces the Bradley's effectiveness and emphasizes the pivotal role it plays in Ukraine's continued defense against Russian armored forces. Combat data indicates that the Bradley's 25mm gun is typically zeroed at 1,200 meters for optimal accuracy. The maximum effective range for the Bradley's gun varies depending on the type of ammunition used. For example, the APS-T, armor-piercing discarding Sabat tracer, ammunition can be effective up to 1,800 meters, while the TP, target practice tracer, ammunition is limited to 1,600 meters. As a result, the effectiveness of engagements largely depends on factors such as ammunition type, target size, and environmental conditions. For instance, at a range of 2,200 meters, the hit probability with TP ammunition is around 27% against a frontal BMP target. A deeper analysis of target hit probabilities reveals a significant variation based on factors like target size and engagement range. At 1,200 meters, the hit probability is 45% for a target the size of a 6-foot square, and this increases to 65% for an 8-foot square target. However, as the engagement range extends to 2,200 meters, the hit probability with TP ammunition decreases to just 27% against the frontal aspect of a BMP. These numbers underscore the critical importance of factors such as projectile dispersion, target size, and environmental conditions in combat situations. Crews must carefully consider these variables, particularly in longer-range engagements, to increase the likelihood of successful hits. Another key factor in combat performance is the crew response time during engagements. The M2 Bradley's advanced fire control system enables faster target acquisition, significantly improving engagement effectiveness. The Thermal Aided Target Tracker (AT) function allows the Bradley crew to track 2 targets simultaneously within the FLARE forward-looking infrared field of view, providing a distinct advantage in complex combat scenarios. Additionally, the commander's independent viewer (CIV) enhances situational awareness by allowing the commander to scan for targets without exposing the vehicle to enemy fire, ensuring that Bradley crews can engage Russian vehicles before being detected. In direct combat situations, Bradley's fire control software (FSCA) automates several critical functions, including calculating laser range inputs, environmental readings, ammunition specifications, and turret control parameters. This automation enables the Bradley crew to hit moving targets on the first round, without the need for sensing rounds. The squad leader's display, SOLD, further enhances the combat effectiveness of the Bradley by providing dismounted infantry with valuable situational awareness before deployment, ensuring seamless coordination between the vehicle crew and supporting ground troops. Recent combat data from Ukrainian operations indicates that Bradley crews who were able to achieve 3 hits within the first 8 rounds demonstrated effective engagement capability. This 38% hit percentage aligns closely with predicted probability models, further validating the effectiveness of Bradley's fire control systems. The integration of advanced thermal imaging and fire control technology has proven to be particularly effective in Ukrainian combat scenarios, where the ability to rapidly acquire and engage targets often plays a decisive role in battle outcomes. Battlefield adaptations. This capability for quick and accurate target engagement is not only vital during direct combat, but also reflects the larger trend of battlefield adaptations that have shaped the performance of both M2 Bradley and Russian vehicles. The intense combat experience in Ukraine has led to significant modifications aimed at enhancing protection against new and evolving threats. As modern warfare continues to rapidly evolve, both sides have adapted their fighting vehicles to meet these challenges, ensuring that their armored platforms remain effective on the ever-changing battlefield. Ukrainian forces have made crucial modifications to their M2 Bradley fleet to counteract modern threats, particularly the rise of drones used by Russian forces. Ukrainian billionaire Renata Akhmetov's Metembus Group has developed metal structures that shield Bradley vehicles from the explosive FIV drones used by Russian forces. The innovative sliding screen system, successfully tested in late 2023, marks a significant step forward in vehicle protection, improving the survivability of vehicles in high-risk scenarios. In addition to the metal structures, Ukrainian modifications also include advanced anti-drone electronic warfare systems, additional reactive armor tiles, and enhanced crew protection features. These countermeasures operate through a combination of signal detection, frequency jamming, GPS interference, and fail-safe triggering, which effectively disrupts the communication and navigation systems of incoming drones. This comprehensive defense system significantly reduces the effectiveness of drone attacks on Ukrainian Bradley vehicles. On the other side, Russian forces have adapted their approach after capturing several M2 Bradleys. The Russian Army's 30th Motor Rifle Brigade has modified at least one captured Bradley by adding a top-mounted camouflaged cage. These modified vehicles are used for a variety of purposes, including direct combat support, medical evacuation, and as a source for spare parts needed to maintain operational Bradleys. However, the Russians face challenges in maintaining these captured vehicles, as the incompatibility between the U.S.-made Bradley and Russian military hardware requires them to rely on cannibalization for spare parts. The experience gained from these combat scenarios has provided valuable lessons on vehicle adaptation. The 47th Mechanized Brigade, for instance, has identified kamikaze drones as a primary threat to armored vehicles. As a result, modifications to Bradley vehicles, such as the Bradley Urban Survival Kit (BUSK), have significantly improved vehicle protection. The BUSK system includes explosive reactive armor tiles, enhanced underbelly protection, additional fuel cell shielding, and improved turret protection, all of which contribute to higher survival rates for modified Bradleys compared to unmodified ones. Combat data further reveals that the proper modifications can significantly improve the survivability of Bradleys in the field. With the U.S. having pledged 190 more Bradley infantry fighting vehicles to Ukraine, specialized maintenance teams have developed procedures for battlefield repairs and continued modifications, ensuring the long-term operational readiness of the fleet. As the role of drones in combat grows, the integration of countermeasures into armored vehicles has become a central focus of military innovation. Russian forces have announced plans to equip their BMP-3 vehicles with mini-drones, signaling a broader trend of incorporating unmanned systems into armored warfare. This shift in design philosophy underscores the rapidly evolving nature of modern combat and the need for adaptive and resilient vehicle designs. Ukrainian forces have enhanced their M2 Bradleys with applique steel and additional passive armor, improving vehicle resilience and providing key insights into future IFV design. These modifications are not only making current vehicles more effective but also shaping the next generation of infantry fighting vehicles. Future combat implications. The combat experience of the M2 Bradley in Ukraine has driven significant changes in vehicle design and tactical doctrine. The lessons learned from these engagements are influencing the development of future IFVs, ensuring they can meet the evolving challenges of modern warfare. These insights are guiding both U.S. Army vehicle upgrades and global trends in armored vehicle design. One of the most significant developments is in the design of infantry fighting vehicles with a focus on enhancing protection, survivability, and operational efficiency. The U.S. Army has initiated the development of the M1E3 Abrams, which incorporates advanced top attack protection systems, integrated active protection capabilities, and improved crew survivability measures. This design evolution also emphasizes enhanced signature management features to reduce the vehicle's visibility to enemy forces, a crucial factor in modern combat. The Bradley platform itself is undergoing a revolutionary transformation with the introduction of hybrid electric technology. The Bradley Hybrid Electric Vehicle, BEV, prototype is expected to offer several key benefits, including a 20% reduction in fuel consumption, a reduced thermal signature for silent watch operations, and fewer mechanical parts, all contributing to a more sustainable and cost-effective fighting vehicle. The increased electrical capacity of the BEV will further support the integration of advanced technologies, positioning the Bradley as a future-proof vehicle for modern warfare. The advancements in vehicle technology have been accompanied by significant changes in tactical doctrine and training methods. With the fielding of advanced vehicles like the Bradley, the Army has revised its operational requirements, introducing 85 new tasks, 44% of which are entirely new procedures. These changes have spurred the development of enhanced digital skills integration, improved crew coordination, advanced target acquisition procedures, and more efficient maintenance protocols. The Army's evolving tactical doctrine reflects the growing versatility of infantry fighting vehicles, which are now capable of performing a wider range of tasks and operating in more complex combat environments. As the integration of advanced technologies becomes a defining factor in modern combat vehicle effectiveness, the Army has recognized the need for substantial investments in armor technology and system upgrades. The proliferation of unmanned systems, such as mini-drones integrated into Russian BMP vehicles, has prompted further adaptations to counter these emerging threats. Ukrainian forces, for example, are actively developing countermeasures against FPV drones and loitering munitions, highlighting the need for ongoing innovation in vehicle defense. The digitization of infantry fighting vehicles also presents unique challenges, particularly in terms of crew training and operational effectiveness. With the increasing reliance on software-dependent fire control and mission systems, the Army has identified the need for specialized maintenance support and continuous updates. Digital skills mastery is now a critical component of crew competency, requiring comprehensive training programs to ensure operational success. Looking ahead, the Army's modernization efforts prioritize key design elements such as multi-layered protection against aerial threats, enhanced mobility through improved power generation systems, and advanced fire control integration for increased lethality. Sustainability is also a focus, with simplified maintenance procedures designed to reduce downtime and enhance operational readiness. The XM30 program, set to incorporate lessons from Ukrainian operations, will continue to drive innovation in vehicle protection and performance, with critical design reviews scheduled for completion in 2024. Meanwhile, developments in Ukraine, such as the Ingor 7 IFV with an unmanned turret and advanced targeting capabilities, exemplify the global trend toward unmanned systems integration and enhanced vehicle protection. These innovations reflect the ongoing evolution of infantry fighting vehicle design, driven by the need for greater survivability, adaptability, and effectiveness in the face of emerging threats. In conclusion, the combat experience in Ukraine has played a pivotal role in the evolution of infantry fighting vehicles, influencing both design and tactical approaches. The ongoing integration of cutting-edge technologies, along with an emphasis on crew training and adaptability, will ensure that future vehicles stay effective in the ever-changing landscape of modern warfare. As these lessons continue to shape U.S. Army development and global trends in armored warfare, it's clear that the future of combat vehicles will be defined by innovation and resilience. What do you think will be the next breakthrough in armored vehicle design?